Thoroughly simplify and state the restriction of the following expressions. Let's go ahead and simplify this. So, oh god. So basically we want to kind of factor the bottom first. So x plus minus 2 and x minus 3. And on the right we will have minus x, x plus 4x minus 3. So we have one common factor being x minus 3. So we just multiply this side by 9x or minus 4x by x. So the top becomes 9x squared plus 36x minus 4x squared, so 5x squared. So 36x plus 8x, so 44x. Over x minus 2, x minus 3, and x plus 4. And what's our restrictions? X doesn't equal 2, 3, or negative 4. On the right, division, otherwise known as dividing by a function, otherwise known as multiplying by the reciprocal of the function. So, oh, actually, no, let's factor first. Why not? Factoring is always our friend. So 6, negative 11, negative 35. Factor that. That will get you 2x minus 7, 2x minus 7, and 3x plus 5. So that's our top over, oh god, a lot of factoring today. 2, negative 1. So that the bottom should be 2x minus 7, so we can actually cancel this out, by the way, and x plus 3. So right away we cross this out. So on the left we have 3x plus 5 over x plus 3. And we're going to multiply. So we just flipped it, flipped the right side. So we have this 1 over the entire right side. So let's see what we have on the right. So on the top we'll have plus 5. So x minus 5 and x minus 5 and x plus 3. And on the bottom we will have 2, negative 5. So we will have x plus 1. No, x minus 1 and 3x plus 5. So notice that this and this cancels out. Oh, I shouldn't have read the lines. This and this cancels out, and 3x plus 5 cancels out. So our final equation is this. X minus 5 over x minus 1. And now we're going to look back into our entire process and see everything in our denominator and make sure that it don't equal to 0. So this is our right at the start. So 2x minus 7. So x doesn't equal to 7 over 2. And x also doesn't equal to negative 3 because of here. And x doesn't equal to positive 1 because of here. And 3x minus plus 5. What is 3x plus 5? What makes 3x plus 5 equal to 0? So negative 5 over 3. X doesn't equal to 1. X doesn't equal to 5. And make sure that this was our top, this was our bottom. So you also include this part. So 1, 2, 3, 4, 5. See 1, 2, 3, 4, 5. And that was 5. And that's all we have. So that's all our restrictions. So x doesn't equal to 7 over 2, negative 3, negative 5 over 3, 1, and 5. Okay, we should have 5 restrictions. Section 4, transformations. And this is the only part where I'm actually not going to be typing it down. And instead, I'll be smart and use a text box. Given the function f of x equals to negative x plus 1 squared plus 5, determine the equation of f inverse of x and graph it. Also state if f inverse of x is a function or not. So right away, we have done this enough for you to know that it's not a function. Whoa, surprising. So how do we actually do this? So flip, let y equal to f of x. So y is equal to negative x minus 1 squared plus 5, and then we kind of replace x. So x is equal to negative, why is Grammarly acting up, plus 5. So x minus 5 is equal to negative y minus 1 squared. So let's take the square root of this guy, square root, and make sure you have the ultimate plus minus sign, which I don't. Plus minus sign here, because you have to include the negative divisions. So now this bracket is gone. So distribute the bracket, negative y plus 1, distribute the bracket. So here, this is what we have. And isolate for y. Oh god, why can't I type? Y is equal to, let's move this entire x here. So plus minus, or we could just do 1 plus minus of the square root of 5 minus x, because we moved the sign here. Alright, so y equals to 1 square root of plus 5. So 1 plus minus square root of 5 minus x. So what is this? We have plus minus. So what will the function look like? We have done this in class enough for you to give us a rough sketch. This is a function. This is always the function. This is always the inverse of a quadratic, because you're reflecting over the line of y equals to x. So this is what you have. So what do we know? We know that no, no, this function, this inverse function is not a function, because it does not pass the vertical line test. And we know that the reciprocal of a quadratic function, that's spell quadratic, right? Quadratic function will never be a function, as the quadratic function fails the horizontal line test. Now we're done. The base function f of x is this not worth 5 marks. This is worth at least 3 marks at max. Anyways, the base function f of x equals the square root of x is transformed by a vertical reflection in the x-axis. So it flips down. Can't draw anymore. So it flips down. So this is the x-axis. So negative a value, negative a, followed by a vertical stretch of 2. So a is actually good to do. So negative 2. A horizontal compression by a factor of 1 over 3. So what does a compression mean? By a factor of 1 over 3. So that means we actually have 3 here. Actually, no, I'll write the function in the space provided. So negative 2 of 3. A horizontal of translation 2 units to the left. So x 2 units to the left, meaning it's actually plus 2. And 1 unit down, so negative 1. Alright, so our function is actually equal to y equals to, notice that whenever we have the bracket, that's where our function goes. So negative 2 square root 3 of x plus 2 minus 1. So this is out of the bracket. This is out of the function, out of the square root. Alright, there we go. Now, create a table values and sketch the graph of the base function and the transform function. Alright, so let's see what transformations are applied to each here. So x, what transformation are applying to x? So 1 over x minus 2. So x over 3 minus 2. Dude, I can't do this. Y is equal to negative 2y minus 1. And you guys can do the sketching here. And this is just dumb work. You guys can do it here and sketch it. It shouldn't be hard. So do that. F of x equals to 1 of x. Graph g of x equals to f of x plus 1 plus 2. Also write the transform equation. So again, you guys will graph it. I'll just do the transformations for you. So we have no a value right here. So all we have is just 1 over x plus 1 plus 2, which is our y value here. All right, let's do section 5, exponential functions, and we're almost closing to the end. So section 5, the car value. David bought a new car for $30,000. Its resale value will depreciate by 22% of its current value every single year. What will his car be worth after 5 years? So, depreciate by 22% also means that 100 minus 22 is equal to 78. So it turns to it's 78% of its value every year. So 78 times n. And our base value was 30k. Alright, so this is our f of n equals to 30,000 multiplied by 0.78 to the power of n. N is equal to the time in years. So you have to actually let n do a let statement. Let n equal time in years. And you also have to do a let statement that you let your model equal to that, by the way, just saying. I'm not going to do it because I'm lazy, but you guys have to do it because you guys are doing it for marks. Alright, 0.78 to the 5th power times 30k. Wow, the car is really worth absolutely nothing. Just saying, it's worth $8,661. Does it say how many values? No, it doesn't. So we will just round it to 2 decimal places. 52. 52, I guess. Put our dollar sign here. Just saying, this question is a little wrong because your resale value actually kind of depends on how much kilometers you drive on the car. The population of a pot of whales has doubled in size recently over a 6-year period. They have a current population of 21 individuals. What might the population be after 15 years? So you should write an assumption statement. So assume our population continues with our current data. You should do that. Anyways, so let's write our model. So our base individual is 21. That's how much we started with. And what's our doubling period? Our doubling period is 6 years. So times 2 to the n over 6. And 6, and you have to do the same let statement. And n equals to 15. So let's do that. So 15 divided by 6, you're getting 5 over 2. So 2 to the 5 over 2 power times 21, you're looking at around 118. So this question, um, I suggest we got the decimal place of 118.79. So usually you round up because it's greater than 5. But in this case, I would say we round down because we're looking at a population right here. So population P of n would actually equal to 118. So your teacher might be looking for a different answer. It could be looking for 119. I would say both of them are correct. It depends on what your teacher is looking for. I will be looking for 118 because you don't have a 119 individual yet. But obviously, it depends. A radioactive isotope decays rapidly with a half-life of 5 minutes. That's pretty quick. For a 25-minute test, technicians need at least 7 grams of the isotope for there to be there at the end of the test. How much should they start with? So this is a really broad question. So we want to know how, like, just a little bit more. So how many doubling periods are there in 25? So 25 divided by 5 is 5. We're going to have 5 doubling periods. So we want at least 7 grams. So that's our least. So this is our final amount. 7 times that. Oh, this is a half-life. So we wanted to have more than 5 times. So or to say you want the amount to start with, you can half it 5 times and it will still equal to 7 grams. So this is how much you should start with. So working backwards, times 7, and that's giving you 224. So they should start with at least. So let n be the number they should start with, at least 224 grams. Always write your unit. How long does it take for 100? How long does it take $100 to grow to 500 if the amount of invested at a rate of 13.5% per annum? That is a lot, by the way, compounded semi-annually. So what's our interest per compounding period? 13.5 semi-annually twice. So our interest rate is 6.75. And Yeah, so we want 500 is equal to 100 multiplied by 1.6.75. Let's divide that by 100 to get a rate. So 0. No, what am I doing? 1.0675 to the you could do n here, or I guess you could do you could do n here, sure. You could do 2n, just do 2n. Alright, let's do this. So let's isolate. So 500 divided by 100. So 5 is equal to, and then we take the log of both sides. I taught you that method because we're doing some AP stuff. So you will get an answer of approximately 12.31 years. So let's work backward and check. So 12.31 times 2, and we get 0.675 to that answer, times 100. So yeah, in 12.31 years, we get 499.36. So close enough because we rounded, and yeah. Trig. Oh my god, it's trig. Draw both special triangles. Alright, so you want to draw your 1, 2, 3. 1, 2, no, what am I doing? 1, 2, 2, square root of 3, and then label your stuff, and then 1, 1, 2, 1, 1, square root of 2. So yeah, label your angles, pi over 4, pi over 4, 90, 90, 30, 60, pi over 6. Yeah, label your angles. Anyways, find the exact value of the following ratios. Show all work and sketch the terminal arm and its reference angle sine 225. So 225 somewhere here. Otherwise, and we will have a 225 minus 180. So 45. 45 degrees. So sine of 45 degrees is equal to what? And also, uh, oh, student take calculus. So our sine is actually negative in the quadrant here. Oh, student take calculus. Oh, student take calculus. So it's negative sine 45. Negatives. So sine 45 degrees. Make sure you don't mess that up. Negative. So it's negative square root 2 over 2. All right. And then secant of 300. So this is 270. So 300 minus 180. So 120 is our angle. So minus 180. So 120 would be around here. Oh my god, that's a horrible graph. 120 of secant. Alright, so we have that. 120, so secant of so that secant is 1 over cos. Just so you remember that, keep that in mind. So cos is actually positive here. So what does secant of 300 do? So cos of 300 degrees is 1 over 2. 1 over 1 over 2 is going to give us 2, and no cosine is positive. Keep that in mind. Alright. Solve the following equations. Round your answer to the nearest degree possible. If necessary, show all your work. Right away. Different ways to do it, obviously. Sine equals to sine equal to, wow, why am I not able to write? Why can't I write? sine is equal to opposite over hypotenuse. Different ways to do it if you want. Doesn't matter. Opposite is 3 and hypotenuse is 5. And 5, 3, you know this is 4. Just saying. Just saying. 25 minus 9, that's equal to 16. Square root of 16 using our Pythagoras theorem gets you 4. So theta, right here, this is our angle. So you can use whatever law you have right now and get it. But obviously, remember that there's going to be, this is pi, theta is going to equal to theta. So let's go ahead and inverse it. So negative, so inverse sine of 3 over 5. It's going to give us a degree of roughly 37. And note that there's going to be two values for it. So 37, so 180 minus 37 degrees. Because student take calc. Sine is only positive in these. So 180 minus 37, it's going to give us 143. So 143 degrees. Oh god, I need some water. It's okay. Secant theta is equal to negative 2. Or to say 1 over cos is equal to negative 2. Or cos is equal to, no, it's negative 1 over 2. So where is cos equal to negative 1 over 2? We can just draw the graph. So here, it's actually a really bad graph. I'm sorry. I should be ashamed drawing that graph. Alright, so this is half point. That's always just inverse it of negative 1 over 2. So where is cos negative? Oh, student, take calc. So cos is negative here. So last question we found out it's 120 degrees here. This gives us negative 1 over 2. So what else? What else gives us the answer? So here, what does this give? So 2. So what angle here gives this answer? 360 minus 120. That's going to give us 240. So theta is equal to 120 degrees or 240 degrees. Alright. Angle K is located in the third quadrant with a secant of negative 6. Find the expression of the other 5 trigonometric ratios for K. Oh, that's a lot of work. So it tells us it's in the third quadrant. It's third quadrant. So third quadrant and a secant of negative 6. Secant is 1 over cos. And then 1 over cos, we're gonna have negative 6. Or cos is gonna equal to negative 1 over 6. So there's a reason why they specify it's this quadrant 3, because that means that our y value is the negative 6. Negative 6. And cosine is adjacent, so this is 1. Oh my god, that's a horrible. I'm sorry, guys. This is our theta. Alright, so quadratic formula. 36 plus 1, so square root of 37. So square root of 37 is... Well, no, it's hypotenuse. I'm so sorry, guys. So this is negative 1. This is 6. So this is square root of 35. Alright. Do your work. So sine is equal to opposite over hypotenuse. This is also negative because of the y value. For 6. And then do the rest. Not hard. Alright, proving trig identity. It's always gotta be your favorite. Always going to be your favorite. So how do we prove this trig identity. So that's no more talking. Talking is not gonna help you solve the trig identity. So over, what is this? Cos times cos divided by 1 minus 1 over cos theta. This is just cos squared theta. This is just cos squared theta. This is not cos squared theta. Minus tan is sine over cos. So cotan is cos over sine. And sine divided by that is just basically of sine. Sine divided by cos over sine is basically sine times sine over cos. So we're having sine squared over cos theta. Alright, so I start on the left. You guys can pick to start on the right, which is also a valid choice. Or if you want, you can start on both sides. I don't usually do that. But okay. So if you do start on the right, you will have cos squared theta over sine theta minus sine theta over cos theta. Everything. Oh my god, this is a minus sign, by the way. Everything over cosecant 1 over sine theta. Or everything multiplied by sine theta. So when you have everything multiplied by sine theta, it's actually easier. So this multiplied by sine theta is just cosine squared theta. Cosine squared theta. So this is going to give us cosine squared theta. And that is going to give us negative sine squared theta over cos theta. Right, remember when you divide by a fraction, you're multiplying by the reciprocal. So by dividing by 1 over sine theta, we're actually just multiplying by sine theta. And then we have to do the distributive property assuming there's brackets. We have to assume there's brackets, or there is brackets, because it's a fraction written in this form. So that and that ls is equal to right side. You're usually not allowed to do this, but I don't care. Determine the equation of both a sine. So you can do that. This is easy. And a Ferris wheel has a radius of 15 meters. So our A value right away is 15. And it's 2 meters above the ground. So plus 2 is our axis at its lowest. Oh, no. So sorry. So our lowest point is 2. So if our lowest point is 2 and our radius is 15, so 2 plus 15, that tells us our axis is plus 17. The right enters located 20 degrees around the rim. Alright, so the Ferris wheel, let's go ahead. So 20 degrees around the rim. So we actually have to account for that. So anyways, we could do a Ferris wheel. So we start on the lowest point, like this. So this is our height. Definitely represented by a negative cos function. I want to do that. So negative to complete the rotations. Alright, you can draw that. I'm not going to do that. So negative 15 cos, we have to figure out here. So theta, and then 20 degrees around the rim before the car gets to its lowest point. So we're actually at some distance here. We're some distance here. So this means we want to shift it a little bit to the right. It's by 20 degrees. And then our axis, as we determine here, is plus 17. Right? So this is our function. And you can sketch this. Negative 15 cos bracket of pi minus 20 degrees plus 17. Model version of cosine. Oh, alright, I already did it. And, last part. Oh, schnazzles. It's the last part. Discrete function. State if it's arithmetic or geometric. Write an explicit formula for the general term. Calculate T10. Algebraically calculate the number of terms in that sequence. Alright, so A, look at this. It's plus 7 every round. So arithmetic A. So I, it's arithmetic. And this one is times 2 every term. Times 1/2 every term. So this is geometric explicit formula. So Tn is equal to I have the answer. 7n plus 9. Yeah, just use your formula, guys. You had a formula for this. I usually give the formula sheet. You can use your formula sheet. T and right here for our right one. Tn is equal to negative 36. special term, 1 over 2 to the n minus 1. Alright, T10 using our formula, so 70 plus 9, so 79. And 1 half to the 9th power times negative 36. Oh, this is our last term. Alright, so I guess that's our last term. Negative 9. So if it's our last term, so this has 10 terms. Algebraically. You can do it algebraically by using our formula, just saying. And n for this one is 82. Just multiply, divide, and use the formula. Jogger runs 300 meters in the first minute. The distance jogger covers decreases by 20 meters in each succeeding minute. What is the total distance does the jogger run? So jogger is following somehow. He's following a arithmetic sequence. So S of 10 is equal to 10 over 2 multiplied by 2 times 300 plus 9 times negative 20 each minute. So this is going to give us 5 multiplied by 600 plus negative. So 5 multiplied by 600 minus 180. And this is all multiplied by 5. Sorry. So 600 minus 180 multiplied by 5. It's going to equal to 2100. So use your formula, guys. You have a formula sheet. Oh God, they have a formula sheet. Wow. Whoa, they give you all this. Wow, this is a brand new treasure. This is why you should always look at your test, guys. Look at your test before you do it. Anyways, T8, T7. So, all right. So if T is T of 8 is equal to 79, and we can expand the formula for this. So you actually have to expand the formula. Use this formula. So use this formula here, but I'm not gonna do it because I already know the answer. So the answer is A equals to 7, D equals to 12, and Tn is equal to 12 and minus 5. And this is one of the questions that I actually want to talk about. So it's the 4th level. What does that mean? Okay. So remember, this is actually floor 0. So right here, floor 0, floor 1, floor 2, floor 3, floor 4. So right here, this is our floor 4. So we will have, obviously, we'll have n plus, so this is our n. So we'll have n plus 1 terms. So little extra. So our first value is going to be 2x to the 4th power. So no y. And our second value is going to be 2 times 3. 2 times 3. It's going to be, here, I'll do it. So we will have, it's going to be x cubed minus y for sure. And our value here is going to be 2 cubed. 2 cubed. So we're going to have negative 96. And then, plus 96 because it's negative. And then plus 216 because we're multiplying by 6 here of x squared y squared minus 216 of xy cubed. And finally, we'll have plus 81 of that is our binomial expansion. You have to show the Pascal's triangle. Anyways, that is it for our final exam review. I hope all of you does good on your final exam. And I'll be studying other courses like advanced functions, and hopefully I get to do statistics because I get to teach an introductory statistics class this semester. Anyways, again, wish you guys good luck and have a great day.